Hello, everyone. Welcome to our construction technology course. Today, we begin the module on reinforced concrete works construction. Our main focus today will be on concrete mixing and batching. Concrete construction includes batching, mixing, transportation, placing, compaction, and curing. Any misstep in any of these processes can compromise the quality of the concrete. Concrete construction must not only ensure that the structural components conform to their design shape, but also achieve the required strength, compaction, and integrity. Let's begin with the raw materials for concrete. Concrete used in construction is a mixture of cementitious materials, mainly cement and lime, coarse and fine aggregates, mainly gravel and sand and water, all combined in specified proportions. In addition, admixtures are often added to concrete as needed to enhance certain properties of the concrete according to their main function. Admixtures can be classified into admixtures that improve the rheological properties of fresh concrete, such as water-reducing admixtures, air-entraining admixtures, and pumping aids. Admixtures that regulate setting time and hardening properties, such as set retarders, accelerators, and quick-setting admixtures. Admixtures that improve durability, such as air-entraining admixtures, waterproofing admixtures, and corrosion-inhibiting admixtures. And admixtures that enhance other performance aspects, such as expansive admixtures and antifreeze admixtures. Besides material preparation, it is also necessary to determine the concrete's target strength and calculate the mix proportions. When designing the mix proportions, the target mix strength must exceed the design strength, in accordance with the code for ordinary concrete mix design. Next, we move on to concrete mixing. The concrete mixing process involves the uniform blending of water, cementitious materials, and aggregates to achieve a homogeneous mixture. Through mixing, the materials are plasticized and strengthened. Concrete can be mixed either manually or mechanically. Manual mixing typically uses the 3-dry 3-wet method. First, cement is dry mixed with sand twice. Then gravel is added and mixed once. After achieving a uniform blend, water is added gradually, while the mixture is wet mixed 3 more times. Mixing is complete when the cement paste evenly coats the aggregates without segregation. Under the same conditions, manual mixing typically requires 10% to 15% more cement than mechanical mixing, and results in poorer mixing quality. It is only used when concrete volume is small and no mechanical equipment is available. The mixing equipment widely used today can be categorized based on mixing mechanism into drum-type and forced-action mixers. Drum-type mixers have blades fixed to the inner wall of the rotating drum. As the drum rotates, the blades lift the concrete mixture upward and let it fall under gravity, achieving a uniform mixing. Drum-type mixers experience less wear on the drum and blades, and are easy to clean, but their mixing power is relatively weak. Energy consumption is higher, and efficiency is lower. They are mainly used for concrete with medium to high workability. Forced-action mixers use rotating blades inside a stationary drum to push and force the materials to move in all directions. Because particles move at different speeds and along different paths, they undergo shear and slip, intermixing and dispersing, which achieves a uniform mix in a short time. To produce uniform, high-quality concrete, it's important not only to select an appropriate mixer type, but also to set a proper mixing procedure, including mixing time, batch size, and batching sequence. Mixing time refers to the time interval from the moment all materials are loaded into the mixer to the start of discharging. It directly affects mixing quality. If the time is too short, the mix may be non-uniform, resulting in decreased strength and poor consistency. If mixing time is too long, productivity drops, and softer aggregates may get crushed, lose their edges in large mixers. negatively impacting concrete quality. Therefore, mixing time must comply with code requirements. Sequence of ingredient addition. When determining the loading order of raw materials, you need to ensure good mixing quality. Reduce equipment wear and cement dust. Minimize concrete sticking to the drum. And improve efficiency and reduce energy consumption. Currently, the most commonly used method is one-time batching method. The typical batching sequence is gravel first, then cement, and finally sand. The advantage of this sequence is that the cement is positioned between the sand and gravel, which helps reduce cement dust as it enters the mixer drum. Additionally, the sand and cement enter first and form mortar, which quickly coats the gravel particles, preventing water from pooling on aggregate surfaces and causing adverse effects. This improves overall mixing quality. To summarize today's lesson, we covered concrete material preparation, mixing requirements, and the mixing process. Let me emphasize one key point. Labor costs are currently very high, and manual work is inefficient. Therefore, always follow this principle. Whenever possible, choose machinery operations over manual labor.